Hello, my name is Santiago, and welcome to 6.7, the fundamentals of calculus and definite integrals. Today we're going to be talking about not just the fundamentals of calculus, but definite integrals. What are those? What are these definite integrals? Well, of antiderivatives. So an antiderivative of a function f of x is a function big f of x whose derivative is f of x, which means it's just like the previous. It's like if I were to say that f of x is like f of x, the small f of x is f prime of x, and regular big f of x is just the regular function. For example, let f of x equals 3x squared and f prime of x equals 6x. The expression 3x squared is the antiderivative. Let me just use this. Is the antiderivative of 6x. Why? Well, because of a simple um because instead of going from, taking the derivative of the x of 3x squared, which would be 6x, instead of doing this, you're kind of backtracking. You're doing a process to 6x to get to 3x squared, and that is an antiderivative. An antiderivative is like the previous version of this. When we take an integral or take an antiderivative, it is taking an antiderivative of the function. The area under the curve is represented by this antiderivative. It's kind of impressive. So it's very simply put, to find an antiderivative is very simple. So the power rule for finding derivative is, you just subtract, you take down the power. It would be n times x times n minus 1. You multiply by the old exponent, which would be n, and you subtract 1 from the exponent. So antiderivative is the reverse order. The first thing you do is add 1 by the exponent. You add 1 to the exponent, and then you divide by old exponent. So the old exponent would be x to the power of n plus 1, and you divide by the old exponent, which was n. Yeah. By the new exponent, not by the old exponent. You divide by the new exponent, not here. Divide by the new exponent. So that would be divided by the new exponent. That would be x n plus 1 over n plus 1. And that is the antiderivative of x of n. And that's basically everything we have for 6.7. Yeah, antiderivatives and the fundamentals and the fundamental theorem of calculus. Yeah. I'll see you later.